All right, so here we are. We have important things to do today. For example, the second sample midterm, which of course just covers 7 and 14. And then eventually when we get to that point, we'll have a sample final, which will bring us through, let's see, hold on one second. All this market structure chapters, which means 15 through 18, that's it. Okay, so we're going through oligopoly. So we'll have one chapter for perfect competition, one for monopoly, one for monopolistic competition, and we'll wrap it up with oligopoly. And that will be the final exam. Not comprehensive, just those last 4 chapters. Okay, but for right now, we're focusing on number 2, midterm number 2, which is 7 and 14, government action in markets, which is our discussion about price ceilings and price floors and tariffs and taxes, consumer surplus and producer surplus, and then, of course, production and costs. We're looking at cost curves as well as production curves. So that was a fairly intensive section, and so that's why there's only 2 chapters on this midterm, because they were very intensive chapters. All right, so let's take a look at this thing. And when we're done, if there's any time left, we'll get back to our discussion about monopolistic competition, and we'll see how that goes. All right, so in the meantime, let's take a look at this. So we have our fill-ins. And so we start out by asking, how is consumer surplus measured? All right, well, I'll do it both in English and with a graph. You can do either one of them on the test. Okay, so consumer surplus equals the difference between what the maximum price that a consumer is willing to pay for a good and the price actually paid. Okay, so in other words, we often find ourselves able to buy a product for less than we are willing to pay for it. And so when that happens, we enjoy what's called consumer surplus. So in the graph, you might recall that we expressed it in the following way. All right, we have our supply and demand curves. So this is the equilibrium price. And whatever that happens to be, I'll call it P star. This shaded region, everything from that price up to the demand curve, represents consumer surplus. Now, the question doesn't specifically ask you for a graph. You can feel free to provide one, or you can actually use the graph in this case instead of the English discussion. The picture says it all. So you can decide in a case like this which one you want to do, or both. Both are fine. You can write it in English, you can draw a graph, and either way, as long as I can see that you understand it, that is perfectly fine. Now, the marginal cost of producing a good. So what we're asking here is how much the cost of producing one more unit of the good. Okay, so in other words, or actually what I should have said was this represents the additional cost of producing one more unit of the good. Okay, in other words, if I'm currently making 100 units of my product and I need to produce one more, how much extra will that last unit cost me? Very good. All right, now producer surplus is from the perspective of the producer. Often they can sell a product for more than the minimum at which they're willing to sell it. So we say this equals the difference between the minimum price at which a producer is willing to sell a good and the price actually received. All right, so the supply curve, remember, represents, actually, let me make this a complete sentence here. Producer surplus equals the difference between the minimum price at which the producer is willing to sell the good and the price actually received. So remember, the supply curve represents the minimum price at which the producer is willing to sell that good. Anything more is obviously welcome, but if we're on the supply curve, remember, all those points represent the minimum price at which we're willing to produce this good. So here, with our supply and demand curves, okay, here's the equilibrium price again. And now this time we're looking at the bottom triangle. This is what we mean by producer surplus. Okay, so again, you can choose to either draw the picture in this example or write out the explanation in English, or possibly do both. As long as I can see that you get it, that's good enough. All right, so just remember, consumer, we're looking at the demand curve. Producer, we're looking at the supply curve. Okay, and the boundary is always the equilibrium price. All right, that's the difference between the two. The one is based on the supply, up here is the demand curve, down here is the supply curve. Now, if you had numbers, you could figure out the actual value by using geometry. And of course, just remember that the area of a triangle is always 1/2 times the base times the height. Here we don't have that information, so you can't actually calculate it. But if you do have the actual numbers, you should have no trouble actually calculating both consumer and producer surplus. All right, now we're getting into the government interferences down here. And so a rent ceiling, a rent ceiling is a maximum price that may be charged for a good or service. Oh, sorry, rent ceiling. I wasn't paying attention. For an apartment or a house. The maximum price. The government will allow a landlord to charge. Rent, not price, rent. Well, although it is a price, it's the maximum rent that the government will allow landlords to charge for an apartment or a house. Okay, now in the second half of this test, where the problems are, you might be asked to actually draw a picture of a rent ceiling. So when you do that, the most important detail is that the price or the rent ceiling has to be set below the equilibrium price. Otherwise, it would have no effect. Okay, so for example, here, let's say we have a rent ceiling. And let's just say that the equilibrium rent in the city is $3,000 a month. So, and the quantity is, I don't know, let's say 1,000, 10,000. It's a fairly small city. Okay, now the government comes along and says, you're not allowed from now on to charge more than $2,000. Now, obviously, that's going to result in a shortage. You can see in the bottom here, the quantity demanded is over here, and the quantity supplied is over here. So quantity demanded exceeds quantity supplied, which means we have a shortage, which is permanent because the price system does not adjust to bring the rent back to where it belongs. Now, the key detail here, though, is that if the government had set the rent ceiling at $4,000, it would have no effect because the equilibrium price is $3,000 anyway. So if you're going to draw this picture, make sure that the rent ceiling is below the equilibrium price. Okay, that's the most important detail. Now, there's many impacts of the rent ceiling, but all of them are bad, by the way. They include things like a rent ceiling causes a housing shortage, for sure. But if you want to add more, it also causes increased search costs. And of course, black market activity. All right, the most important one is, of course, the one on top, the housing shortage. That's all you need for this case, but it also, of course, increases search costs and black market activity. Now, black market, this is a market where goods and services are sold illegally. Now, this actually, a black market can cover a lot of possibilities, but technically, the reason why it's called a black market is because it's technically illegal. Even if you're trading perfectly legitimate goods, like, for example, in a country like Venezuela, where the economy is completely collapsing, there's a black market where people buy and sell dollars. Now, normally that would not be a problem, but in Venezuela, that is technically illegal. And so that is considered to be a black market. It can also involve other activities, like, for example, as you know, during the summer, construction companies need a lot more workers, and sometimes they may decide to pay them off the books, which means they slip the money under the table without the IRS ever finding out about it. That's technically a black market, because technically what they've done is illegal. But the bottom line is that it's simply a market where the activities themselves are illegal. It doesn't have to be like dealing drugs or something like that to be a black market. It could be any activity where it's technically illegal, like trading currencies in Venezuela, or paying people off the books and that type of thing. What is one effect of a minimum wage? Okay, well, the minimum wage, as we know, has one guaranteed effect, leads to a surplus of labor, specifically unskilled labor. It means that there's a lot of people who will no longer be employable because they don't have enough skills to justify paying them the minimum wage. It's really just that simple. Especially these people who want $15 an hour, that's a lot of money. So you have to be able to produce a lot to justify a salary of $15 an hour. And if you're just a high school student who's trying to earn a little extra money on the side, it's not likely that somebody's going to pay you $15 an hour. If you're working, let's say, in a McDonald's or something, it just isn't worth their while to pay you. And so those jobs just disappear and they never return. Okay, now if a tax is imposed on the seller of the good, so this is going back to chapter 7. So you might remember, although the diagrams were very, very complicated, the most important detail here is that when there's a tax on the seller, the supply curve shifts to the left. So if you want to draw this, you can, to help remember, but you'll notice that even without any of the other curves or other information, the bottom line is that a tax imposed on a seller reduces the supply of the good. Because it's more expensive for the seller to produce the good, therefore less will be produced. It's really just that simple. Now, sometimes that's the point of the tax, like with tobacco taxes. The reason why the government slaps such enormous taxes on cigarettes is because they know that, well, they're hoping that smokers will quit. And there's also taxes on other things like alcohol, for example. And, part of the motivation there is to maybe minimize or discourage the use of alcohol. So, in fact, in the past, taxes on alcohol and tobacco were often called sin taxes, because let's say that it was a more biblical time, let's say, when those are considered to be, let's say, activities that were not approved of. So, but the point here is that a tax will reduce the supply of the good. And that means that the cost of the good will go up to the consumer. The only question is how much will it go up? Now, on the other hand, if this tax is imposed on the seller of a good when the price elasticity of demand is zero, now this one requires a little bit of more complicated graph. Remember what it means to have an elasticity of zero. That's the vertical demand curve. Okay, that means that whatever this product is, it's something that people need a fixed amount of. Having more of it doesn't do them any good. Having less of it doesn't do them any good. For example, what if this is the market for insulin? And let's say that diabetics have to have a certain amount of insulin to survive. Now, I don't know if this is true or not, but let's just say that if they don't get enough, they'll have severe health consequences, but having more doesn't help them at all. So they'll buy a fixed amount no matter what the price is, because that's what they need. Now, if the supply is then shifted, let's say from here to here, you can see that if the tax, whatever the tax is, $T, the market price goes up by exactly $T. So whatever this is, let's call this P star plus T. So in other words, the point of this one is that the sellers are going to pay the entire tax. And just as in general, I just want to remind you, just as a quick rule of thumb, the burden of the tax will fall more heavily on the consumers if the price elasticity of demand is very low, as it did here, and on the producers if the price elasticity of supply is very low. Okay, so just remember here, because the price elasticity of demand is so much lower than for supply, that means most, in this case, all the tax is being paid by the consumer. All right, just as a quick way to help you remember these relationships. Now, on the other hand, we'll put this to a test right now. If we impose a tax on the seller when the price elasticity of demand is infinite, all right, let's take a look. Oh, by the way, I just realized I want to make one little change here. Instead of is very low, I want to change this to relatively low because it still matters. In other words, what we're really trying to capture is which one is lower, the price elasticity of demand or supply. So let's change this to relatively low, which means compared to the other one. In other words, they could both be fairly high, but if the elasticity is higher for supply, then the consumers will pay most of the tax. So here, the opposite case is happening. Here we have the elasticity is infinite. So look what happens. The market price hasn't changed, which implies, in this case, market price doesn't change. Therefore, the seller is paying the entire tax. And you notice the logic here. The supply, the elasticity of supply is relatively low compared with the price elasticity of demand, so that the producer ends up paying, in this case, all of the tax. Okay, usually it's not all of it, it's most of it. So here, because the price elasticity of demand is so much higher than supply, the supply's elasticity is relatively low, and therefore they end up paying most of the tax. Okay, so I hope that helps you remember this. If not, just draw the pictures. And of course, don't forget that an infinite elasticity of demand is the flat one. Okay, the price elasticity of demand is infinite when it's flat. That's true for the supply curve too, by the way. So in other words, any flat curve means the elasticity is infinite. Any vertical curve means that the opposite is zero. Okay, so price elasticity of demand. Okay, so you can see here, the price elasticity of demand is much lower than the price elasticity of supply, so that the burden of the tax falls mainly or completely on the consumer. Okay, so that's how the rule works. In other words, here the demand, the elasticity of demand is much lower than supply. Therefore, the consumer pays the tax. Down here is the other way around. The supply is relatively inelastic compared to the demand, and therefore the producers end up paying the tax. Okay, so again, you can either remember this rule of thumb, or else you can draw the pictures. All right, so now we're done with that. So now the marginal product of labor, again, you can do this in English or with an equation. The marginal product of labor, or both, equals the change, I'm going to emphasize that with the italics, in total product divided by the change in output. By the change in labor. There we go, that's better. All right, so the equation then is very simply okay. So in other words, you could write that as well. Of course, it means the same thing. All right, now let's see what's next. The law of diminishing returns. Okay, so this is all about the way output changes when we use more and more of a variable input. So when more of a variable input is used with fixed inputs, output at first increases at an increasing rate, then increases at a decreasing rate, then it decreases. Okay, so there's three stages. It increases at an increasing rate, then it increases at a decreasing rate, and then it starts to become negative. Okay, so in other words, let's say up to about here, increases at an increasing rate, then right up to the point where it peaks out there, increases at a decreasing rate, all through this region here. I'll give it little dots. How about that? Just to keep it separate from the slashes. And then it decreases. All right, so that's really what the law of diminishing returns is all about. How does output react to changes in a variable input when all the rest are fixed? And of course, we see this, like we mentioned, this example of studying time and, basically any other activity that you're engaged in the short run, you're going to eventually experience diminishing returns. All right, now a fixed cost is one that does not change as output changes. Okay, so if you wanted to provide some examples, you might, for example, the rent on a Starbucks store does not depend on the amount of coffee being sold. It is a fixed cost. Okay, so they have to pay X dollars to the landlord every month, regardless of how much coffee they sell. That's what makes it fixed. All right. Now, of course, variable is the opposite. Those are the costs that increase directly as output goes up. That would be, for example, the coffee beans in this case. Unless they've discovered some artificial coffee that nobody ever heard of before. Oh, and eventually it'll happen. It's like these meatless hamburgers they have now. I've never had one, but supposedly they're okay. Yeah, I wouldn't be surprised if one day we start to see coffee beanless coffees. It might happen. You never know. But anyway, what happens? Oh, technology. So technology, as technology increases or improves, the total product curve shifts up. So, for example, it doesn't have to be parallel, but as long as it increases, like something like this, to something like this. Let's call this 1 and 2. And again, the graph is not absolutely necessary unless you want to. If you do want to just draw the graph, that's okay too, where you can provide both an English explanation as well as a graph, or just a graph, or just the English. As long as I can tell that you know what you're doing, that's fine. All right, now what else? Ooh, which type of average cost continuously falls as more output is produced? That would be average fixed costs. And why is that happening? This is because fixed costs do not change as output is produced, as more output is produced. Okay, so in other words, AFC equals total fixed costs over Q. So if Q keeps increasing as output, or Q increases with no change in TFC, this ratio declines forever, basically. Okay. So in other words, the logical explanation for this is that you've got a constant being divided by a progressively larger denominator. And so the curve itself, of course, will continue to drop. Well, all right, let me try that again. Not a really good effort here. Okay, that's not terrible. All right, it's a fair graph. It's adequate. It's not great. All right, now we're ready for some problems. So here we go. Oh, here we go. We've got actual numbers. So let's figure out the consumer and producer surplus. So why don't we take the approach of geometry? Okay, why not? So what we're aiming for is, let's see, up here we have consumer surplus. One half base times height. The base in this case is 100 for both of them, by the way. And then the height is right here, $10. And that gives me $500. The producer surplus, same thing, one half base times height. And just by coincidence, they're both the same. It doesn't always work out this way. Sometimes it does. Okay. Now, if you don't want to do it that way, you can just go ahead and type it out. For example, consumer surplus equals half of the base times the height equals 0.5 times 100 times 10 equals 500. And the same thing can be said for producer surplus. Okay, that should do it. Perfect. Part B. Ooh, now this is going to be a tricky one. A tax of $2 is imposed on the seller of this good. So here's what I'm going to do. I hope I can still recycle. Yeah, there it is. Okay, so I need to impose a $2 tax on the seller. Oh, it just wants you to, oh, I see. Okay, maybe in part C. No, okay, no calculations, just show it. Now, of course, this is a graph. Nobody is expecting you to be a graphic designer or an engineering drawing specialist. Just do what you can. It's supposed to rise to 1150 and have a quantity of 80. So that would be roughly right around here. The only thing is try to make it parallel with the original curve, supply curve. Okay. But like I said, this is not an art class. The idea here is that the tax is meant to be $2. So the vertical upward shift here is $2. If you had a ruler, let's say, you could show that at every point, the new supply curve is $2 higher than the old one. And so this is where they cross. And so you can see, if you were asked to do so, and I'll just put this over here just as an added bonus, since the tax is $2, the seller now receives $11.50 for the market price, but they have to pay $2 for the tax. Okay, the buyer now pays $11.50 instead of $10. So how did they split the tax? I'll sneak that down here. As a result of the $2 tax, the seller pays 50 cents because they're collecting $9.50 instead of $10. In fact, you know what? Let's do it this way. And the consumer pays $1.50. Okay, so the tax was split to a certain degree, but not equally. And since the consumer paid most of the tax, that would imply that the demand is relatively elastic. Okay, I'm sorry, inelastic. Okay, now let's go down to the next one. Oops. So we've got another diagram. A rent ceiling is imposed of $500 a month. Okay, the equilibrium is 1,000, but the rent ceiling is 500. So without the rent ceiling, the price in the market would have been $1,000. And we would have had 10,000 rental units. Okay, now prior, let's see, I'll probably just do a copy of this. We need to calculate the consumer and producer surplus before and after the rent ceiling. So we'll need 2 copies. All right, so here's what we had before. You don't need, well, the letters, you can use that to help analyze different other questions that we're not going to see here. Like, for example, you can actually use this to calculate the so-called dead weight loss and that type of thing. But right now, we're only focused on consumer and producer surplus. So the consumer, we have this piece. This is in equilibrium. So the base is up to 10,000. Remember, there's 10,000 units being rented in equilibrium. The height is right here. All right, so what does that work out to be? 5,000 times 2,000 is 10 million. Ooh, 10 million. There's our producer surplus. And then, okay, the height is different. This, yeah, that's right. So for the producer's perspective, the base is still 10,000. The height is only 1,000. So the producer surplus is $5 million. Okay, so the consumer surplus is 10 million. And the producer is 5 million. Okay, so we start out there, and then we want to know what happens when the rent ceiling is imposed. Okay, so let's come down here. Let's see. I don't know if this is going to fit, but we'll give it a shot. No, that's all right. It doesn't have to be on the same page. So now everything's different, isn't it? Yes. So the consumer surplus, now the rent is only $500 a month. But let's see, hold on. So in the new situation, we have 5,000 units are being produced or rented at $500 each. Okay, so that's kind of a problem because that sharply reduces the producer surplus. So the new rental price is 500. And the quantity is 5,000. The shortage now you can see here that the quantity demanded is 1,000 rather. But the quantity supplied is only 5,000. So there's a shortage of 10,000 units. Now, the black market price, now we're making an assumption here. We're assuming that the landlords are standing there saying, you know, everyone, if you still want to live here, you've got to pay me the free market price. At $500, I could be getting $2,000. So we're making an assumption here that people will put money into the landlord's pocket to compensate them for the rent ceiling. And so in other words, if you look at the demand curve, people would have been willing to pay $2,000 for 5,000 units. So what's going to have to happen here is that the landlords, let's assume the landlords charge a $1,500 kickback, I guess you could call it. If not, then there's going to be an enormous amount of deadweight loss. So we're assuming here that there's a kickback. Oops. And that means all of this is the kickback. And that brings the black market price up to $2,000. In other words, they're going to try to charge between the rent and the bribe what they would have gotten in a free market had the units been restricted to 5,000 units. So if you can imagine, it would be as if the supply curve was shifted up here. Okay, so in fact, we could actually show that. Anyway, so what we're trying to illustrate here is that there's all of this kickback money coming into the landlord's pockets. And so the black market price is $2,000. Now, what that does though is that it adds a lot back to the producer surplus, but not enough to compensate for the extreme loss of consumer surplus. So the new consumer surplus is just this tiny little triangle. The base is only 500 and the height is only 1,000. So that's a pretty significant loss. So that would give us 250,000. It used to be, what was it, 10 million or something like that? But so let's make a note of that here somewhere. The new consumer surplus is 250,000. On the other hand, the producer surplus is all of this bribe money plus this triangle down here. So I'll change that color, but let's keep in mind this entire region, B, C, and F, is now our producer surplus because we are actually collecting that money. So that's a little bit more challenging to draw or to calculate because we have to include two rectangles and a triangle. So let's do that. The new producer surplus. So the rectangle B has a base of 500 and a height of 1,000. So does C. Well, actually, no, C only goes up to 500. And then you've got the triangle.
You can close the door because I like the door closed. Thank you.
Okay, so the base is 500 again, and the height is 500. That's triangle F. So actually those letters are coming in handy, aren't they? So we've got 500, let's see what this adds up to. $875. Okay, so even with the bribes, the producer surplus is only 875,000. Now that's still a big loss. Imagine what it would have been without the bribes. Now, what we'd like to do, it doesn't ask us to do this, but we want to compare the two. Original consumer surplus was, yeah, look at that, 10 million. Ooh, man, that's a huge loss. The original producer surplus is equal to, and still it's much higher, 5 million. Wow. Ooh, we lost a lot. All right. So 5 million. So the original total surplus is 15 million. The new consumer surplus is 250,000. The new producer surplus is 875. The new total surplus, that adds up to no, something's not right. Hold on a second. I think there's a mistake in here somewhere. I knew it couldn't have fallen that much. Let me try that again. 1,000 times 250. 250,000. No, that's fine. I think the producer surplus is off. Hold on one second. It looks like too much. No, that's it. So anyway, the bottom line is the difference between these two $1,125,000. So the dead weight loss is the difference between the two. Man, that's a big loss. Ooh. Okay, now it didn't ask for all this, but if you did run across a question that did ask you for this, you'd know what to do with it. 13,875,000. Okay, well, that's a pretty big loss. Man. Anyway, let's go on to the next part. Starbucks buys new coffee bean grinders. The following table shows the number of 1-pound bags of coffee that can be ground each day for different quantities of labor. So we're going to need to figure out the average and marginal product. So what I think we should do is fill in a new table with two more columns rather. And so then we can see what we're doing better. So we need two more columns, one for average product of labor, and let's get another one in there. All right, so, and we can drag this over here a little bit. Average product of labor, total product over the quantity of labor. The marginal product of labor is the change in total product over the change in labor. Okay, now, of course, both of these are undefined in the first row. But what happens after that? So the averages are easy. Here we have 25 over 1 equals 25. Here we have 55 over 2, which is 27.5. Then we have 75 over 3, which is 25 even. Then we have 90 over 4, which is 22.5. And 100 over 5, which is 20. These are the tricky ones. Now, keep in mind, we're trying to figure out how much total product changed when we use one more unit of labor divided by the change in labor. So this one 25 minus 0 over 1 minus 0, which is just 25. Okay, so let me see if I can squeeze all that in here. And then for the next one, we increase the bags up to 55 as we increase the labor by 1. So that ratio is 30. All right. So then for the next row, we went from 55 to 75 when we added a third unit of labor. So that one's equal to 20. Then we have 90 minus 75 over 4 minus 3, which is 15. And if you notice the marginal product, it went up a little bit and then suddenly it started falling, which is what you would expect. And with the average product, it went, same thing, went up for a while and then it started coming down again. And then we have 100 minus 90 over 5 minus 4, which is 10. So this is exactly what we'd expect to see. The pattern is exactly what we would normally expect. At first, both of these rise, but then they start falling. And then once they start falling, they continue to fall forever. And that's, again, a reflection of diminishing returns. That's all we had to do there. Okay, good. Then we have this enormous table. Now here, what we have to do is figure out the total and average product of labor. Oh, here are the boxes already there. Nice. Okay. Well, oh, I see what happened. This one is, oh man, this one is a pain because we kind of have to work it backwards. I'll tell you why. Because instead of being given the total product and being asked to calculate the marginal, we're going to do it the other way around. Okay, I know it sounds strange, but it's not that difficult because all you have to do is think about it this way. If the marginal product of the second unit of labor is, let me write out the formula real fast. All right, marginal product of labor. Delta TP over delta L. So for example, if MP equals 50 and the change in labor is 2, that implies that the change in total product of labor is 100. And so what we're going to do is add 100 to this number. 100 plus 0 is 100. All right. Now, for the second one, MP equals, the marginal product of labor is 80. So based on this logic, and again, if you notice in this table, in each case, the change in labor is always 2. Okay, so therefore, if this is equal to change in total product over 2, that implies that 160 is the total product. a marginal, sorry, change in total product must be 160. And so therefore, we're going to add 160 to the previous level of output. Okay, and so all of them will work in exactly the same way. For example, the next one, you see, we're adding double the marginal product to each one. So here we'll have 260 plus 200 equals 460. And then the next one, 2 times 115 is 230. Then the next one, we double 125, we get 250. Okay. Now, 1 second. All right. And then the next one, double that is 266. That gives us 1306, 1206. Okay. Then we'll have 1206 plus double 139, which is 278, 1484. Then double 143 is 286. And that's 1770. And then double that again is 286, which is 2056. And then 2056 plus 280 equals 2336. Now the average products are simple because we can now divide by the amount of labor that we're using. In each case, 260 over 4 equals 65. 460 over 6 equals 75, approximately 75.67. Then we have 690 over 8, and that gives us 86.25. And then 940, 940 over 10 is, of course, 94. 1206 over 12 equals 100.50. 1484 over 14 equals 106. 1770 over 16 equals 110.63. 2056 over 18, 114.22, and then finally 2336 over 20 equals 116.80. Well, that was a pain, but we did it. And hopefully you just get the logic behind what just happened. So we're kind of working this from backwards a little bit by going from marginal product to total rather than the other way around. It's a little harder, but I'm hoping you can see what we were doing. Because remember, it just reinforces the idea that the marginal product simply means how much extra output did I get from each of these workers. So if there were 2 extra workers with a marginal product of 50, I must have gained 100 units of output. And that's why my total product went up by 100. And then the marginal product goes up for a while and then peaks out, and then it starts to fall. All right, so now the next and final table involves cost of production. Wow, this is an intensive one. So this is gonna take a bit of time, but we can do it. All right, yes. So just as a quick reminder, let me just remind you what these functions or equations look like. Total cost equals total variable plus total fixed cost. Average fixed cost is total fixed cost over Q. Oh, all right. In this case, we're calling it TP. Total product in Q means the same thing. I just want to point that out. So let's put TP here. All right, now, what about the others? Average variable cost equals total variable over total product, total cost, average total cost. You can just add these two together or just do total cost over TP. And of course, the marginal cost is the change in total cost divided by the change in total output. Okay. Okay, very good. So we're going to do that right now. And so now the total fixed cost, where's that coming from? Capital is fixed. Each unit of capital costs $40. So if we need to use 30 units of capital to produce this product, and each unit costs $40, that implies that our total fixed costs, which I'll put down here somewhere, must equal the product of 30 units of capital times $40 each, which is $1,200. So our fixed costs are $1,200. So we can just fill that in directly. And since I'm using a computer, I can just copy and paste. The variable cost is the labor. Labor costs $20 per unit. So what I'm going to do is go through and multiply each one of these labors by $20. So for example, at the next row, I've got 2 labors, which means $40. And then that goes up to 80, 120, 160, 200, 240, 280, and finally 320. Then the total cost is just the sum of these 2 columns. Okay, so that's easy. Now, these, in each case, I'm taking the corresponding total and dividing by the output. Now, here, everything is undefined because otherwise we're dividing by 0. So here, for example, I've got 1,200 divided by 20 because our total product is 20. 1,200 over 20 is $60. For the next row, I've got, again, 1,200, but now it's being divided by 33, and that reduces it to 36.36. So you can see what's going to happen here. Each time I move up, I'm still dividing 1,200, but by a new number, in this case, 48. All right, so they're all going to be the same. And since we're running out of time, let me just quickly fill them in. And of course, you'll have a copy of this. And let's see. And, if you get stuck, if you forgot how this works, you can always send me emails. Now, average variable cost, this is different because the variable costs are just increasing steadily, 40, 80, 120, et cetera, et cetera. In each case, I'm simply dividing by the total product. So this one is 40 over 20. Then this one is 80 over 33, which is 242. And then we have 120 over 48, which is 2.5. And so I'll just fill in the rest of them. Now for average total cost, probably the quickest thing to do is just add these two together. All right, let's do that. It's not the only way, but I think it's the quickest way. And also, I just want to point out that you might run into some rounding issues as you go along. So don't be concerned about small rounding problems. And then finally, the marginal cost is the trickiest one. You're taking the change in total cost, meaning here. But if you notice, the change in total cost is always $40. So for example, here, the increase in total cost is 40, and that's divided by the change in total product, which is 20. So this one is 2. Okay, so this equals 1240 minus 1200 over 20 minus 0. All right, so the average fixed cost, I might as well throw this in here. Well, actually, you have the formulas below, so I guess I don't need this one. All right, so let me just quickly finish the rest of them. 308, 267, 308, 4.44, 5, and 571. Okay, so that nightmare is over, but the most important thing is to make sure you can reproduce these with your calculator. These are the formulas down here. That with that one extra piece of information that the total fixed cost is the cost of labor. Sorry, capital, since capital is the fixed input. And then total variable cost is $20 times the quantity of labor, since labor is the variable input. Other than that, you should be fine. So just take out the calculator and go through and double check. Make sure you can understand all of these, where they came from. So, all right. Now, since this one is kind of a messy test, it's a very messy. Now, the actual test is not quite as intense as this. This is just, think of this as like the worst case scenario. So, you can breathe a bit of a sigh of relief. So I think a week will do for this one. Why don't you try to have them ready by next Friday at midnight? I think that would be quite sufficient. So I'll post these on Blackboard, and then you'll have this to study from. And the actual test is on Blackboard. Or if it's not, I'll make sure that it's there. And so I guess we're out of time. So I'll see you all on Tuesday. But if you have any questions about this in the meantime, just send me an email. All right. Any last minute questions? All right. If not, then I'll just see you all on Tuesday and have a good weekend.
Thank you.
Okay.
Thank you.
All right. Bye. Okay. Bye. Oh, don't worry, it happens. When that happens, I can turn it off on my side. It's easy to forget about it. Yeah, it's okay. Don't worry about it. As long as you didn't say your social security number out loud or something like that, you're fine. Okay. Usually what ends up happening is people don't realize it's on, and then there'll be noise in the background, and then the cat is coming in, and then the baby's running around, and then everything is going on in the background, and then so it's fine.